Yeah, so to find the total surface area of the capsule, the formula is CSA of cylinder plus CSA of two hemispheres. Two hemispheres. So CSA of cylinder 2 pi RH plus CSA of two hemispheres. One hemisphere is 2 pi r square. Two hemispheres, 2 into 2 pi r square. So 4 pi r square. The radius is the same for both the cylinder and the hemisphere. So you can use the same letter R. Now what's common? 2 pi r is common. So we have h plus 2r. 2 into, we'll have to take 3.14 for pi into radius 0.25 into h. H is the height of the cylinder, not the height of the capsule. Where is h? In this formula, 2 pi r h, where h is the height of the cylinder and not the height of the capsule. The height of the cylinder is given there. No, it's marked there 1.5. 1.5. Or else you can find the total height is 2 minus the height of the hemispheres. Minus 0.25 minus 0.25. The total height, 2 centimeters, minus the height of the two hemispheres, 0.25, 1.5. It's also given to you there straight away, 1.5 plus 2r. 2r meaning 2 into 2.5. 2 into 2.5. Oh, not 2.5, 0.25, sorry. 2r, 2 into 0.25. 25 into 2 is 50 and 2 decimal places. So 0.5, 0.5. So what does this give? 2 into 3.14 into 0.25 is 1.57 into 2. 1.5 plus 0.5 is 2. Yeah, so Bhavishya is right. And the answer in the book, option D, 3.14 centimeters square. Good, Bhavishya. The others must either identify your mistake by yourself or you can ask me. Somebody said A, somebody said C. But the correct option is D, 3.14. All of you get that? Okay, the next one, two identical solid cubes. Two identical solid cubes of side K units. See, nobody is responding, so I didn't ask any further questions. Do you have any questions, any doubts here? Somebody got A and somebody got C. Found your mistake?
Yes, ma'am.
Yes,
Okay. Next one. Two identical solid cubes of side K units are joined end to end. I'm not drawing a cube. I'll just show a square like this. Okay. So two identical solid cubes of side K units are joined end to end. What is the volume in cubic units of the resulting cuboid? So imagine this when you stick two cubes together like this. The length of the new cuboid, the length of the cuboid will be K plus K, 2K. Breadth this side will be K only. Breadth is K. And the height also is K. Only the length becomes K plus K, 2K. The length of the cuboid. Two cubes of edge K units. So K, K. The resulting solid is a cuboid of length K plus K, 2K units. breadth will be K only. Imagine that. Two cubes, they are stuck together. The breadth will be K units. And the height also will be K units. Because it's a cube, no? Length is equal to the breadth is equal to the height. So the volume of the resulting cuboid will be L into B into H. Oh, I didn't ask you. Oh, sorry. So it's 2K cubed. Am I right? 2K
Yes,
cubed.
ma'am.
So the option
Yes,
A
ma'am.
is it?
Yes, ma'am.
A, option A, ma'am.
Option A. Very good. Yeah, very good. Option A. Next one, the radius of a sphere whose volume is 12 pi. What's the answer?
Option C, ma'am.
Option C, is
ma'am.
it?
Yes, ma'am.
C.
Yes, ma'am.
3
Okay.
power 2 by 3.
3 power 2 by 3 centimeter.
Okay. So sphere volume formula is 4 by 3 pi r cube. And this is given to be 12 pi. Volume of a sphere 4 by 3 pi r cubed is equal to 12 pi. So pi on either side gets cancelled. So r cubed is equal to 12. 4 by 3 becomes 3 by 4 here. 4 by 3 becomes 3 by 4. So 4 ones are 4 threes are. So r cubed is equal to 3 into 3, 9 or 3 square. Okay, so r will be equal to, r is equal to the cube root of 3 square. Because the option there is in this form. So that's why we are not writing 3 square as 9. R is equal to the cube root of 3 square. So R is equal to 3 square. This is the radical form. So the exponential form will be to the power 1 by 3. Which, sorry, which is 3 to the power 2 by 3. Four by 3 pi r cubed is equal to 12 pi. Pi gets cancelled on both the sides. R cubed is 3 square. 4 ones are 4 threes are, so 3 into 3, 3 square. So R is equal to the cube root of 3 square. So cube root of in the exponential form is to the power 1 by 3. So we get 3 to the power 2 by 3. Question number 4, is this the same question we did yesterday? Or
Yes,
similar?
ma'am. Same
Yes,
question.
ma'am. Yes, ma'am.
So then I'm not, we'll not discuss this, children, because I think we discussed this yesterday, right?
Yes,
Yeah, right?
Yes,
We
ma'am.
did discuss the answer also. Okay. So what's the answer for this one? Fourth one, which option?
1 1
11200.
Correct. Option B. Option B. Correct. 11,200. Okay. Next one. Have you found that? Which is the correct option?
363, ma'am. Option C.
Option C, ma'am.
63.
Option
Correct. Okay.
363.
Correct. A cubical ice cream brick. A cubical ice cream brick. So you get this family pack, no? What is sold as a family pack? So it's a brick. It's like a brick. It's a cubical ice cream brick of edge 22 centimeters is to be distributed among some children by filling ice cream cones of radius 2 centimeters and height 7 centimeters up to its brim. How many children will get the ice cream cones? See, so normally ice creams are sold like this. Ice creams are stuffed in cones and they also have a hemispherical topping. But here that hemispherical topping is not mentioned here. Okay, so this ice cream, the whole ice cream is a cubical brick. The entire ice cream is a cubical brick, and that is distributed to children by filling the ice creams into cones of radius 2 centimeters and height 7 centimeters up to the brim. That hemispherical thing is not there. How many children will get the ice cream cones? So it's filled like this. The cones are filled with ice cream like this. No hemispherical top because it's not mentioned. It's only filled to the brim. Okay. So the equation is number of ice cream cones is equal to, not a number, volume of ice cream in all the cones is equal to volume of ice cream in the cubical brick. Volume of ice cream in the cubical brick will be equal to the volume of the ice cream in all the cones. Volume of ice cream in the cubical brick. This ice cream, the volume of the ice cream here will be equal to the volume of the ice cream in all the cones, filled in all the cones. So what's the volume of the ice cream in one cone? 1 by 3 pi r square h. So in all the cones, we don't know how many cones. So n into 1 by 3 pi r square h. Volume of ice cream in one cone is 1 by 3 pi r square h. In all the cones, we don't know how many cones. So let the number of cones be n. So n into 1 by 3 pi r square h is equal to the volume of the ice cream in the cubical brick is h cubed, right? So now fill the values n into 1 by 3 into pi. Any instruction? Pi, no instruction is given. So 22 by 7 into radius 2 into 2 into height 7 is equal to 22. All in centimeters, no? Yes. So 22 into 22 into 22. This is the formula to find the volume of a cube. So n is equal to 22 into 22 into 22. Now the numbers in the denominator here will come to the numerator on the other side. So 3 and 7. Oh, you can cancel 7 and 7 here. So this 3 will come to the numerator on the other side. So into 3. And this 22, 2 will come to the denominator on the other side. N is equal to. So 22 and 22. 2 ones are to 11 times. 2 ones are to 11 times. So N is equal to 11 11s are 121 into 3, 363. Right. Very good. Now that we have seen a question like this, this should not see every time you should read the question and get the information. You should not have any fixed data in your mind. Now, next time you see an ice cream question, you should not assume that the ice cream is filled only in the cone. The ice cream in that question may have a hemispherical top. So you should always read the question. Just because we have encountered a question here where the ice cream is filled only in the cone without a hemispherical top, this should not fill your mind. Another question about the ice cream may have a hemispherical topping. So always read the question. So here it is like this, N363. Any questions? Okay, next one. Yeah, the correct option for the sixth one is
D, ma'am. 19.4.
19.4. This is question number 6. 6, yeah, the book says D, option D, 19.4. So let's see. The volume of the largest right circular cone that can be cut out from a cube, largest right circular cone that can be cut out from a cube of edge, 4.2 centimeters is. Okay. I can't draw, but I'll just try my best. No, I'm going to fail. So let me not try that. So you imagine a cube and you have to identify or you have to find the volume of the largest cone that can be drilled out from this cube. Now we know that every surface of a cube is a square, and you know that you can draw a circle touching all the sides of the square. You cannot draw a circle touching all the sides of a rectangle. No, I don't know what I said. You cannot draw a circle touching all the sides of a rectangle. You cannot draw. See, this circle can touch this side and this side of the rectangle, but it doesn't touch these two sides. So a circle can be drawn inside a rectangle, can be drawn inside a square. But when you draw, you can draw a circle in a square touching all the four sides. You can also draw a circle not touching all the four sides. That's a different thing. You can also draw a circle not touching all the four sides. So the biggest circle that can be drawn is a circle touching all the four sides. But in the case of a rectangle, see, you can draw. Now, if the rectangle were like this, you can draw a circle like this. So in a rectangle, you cannot draw a circle touching all the four sides. The circle will touch only the opposite sides, a pair of opposite sides. So with this, you can understand that the maximum diameter the circular base of the cone can have, the maximum, the biggest, the largest diameter, the base of the cone, which is a circle. The base of the cone is a circle, right? So the largest or the maximum diameter it can have is the edge of the cube. What's the edge of the cube? 4.2. 4.2. Diameter is the edge is 4.2. So the radius of the circle will be 2.1. The maximum diameter is 4.2. So the maximum radius possible is 2.1. So this will be the radius of the cone, 2.1 centimeter. The height of the cone will be the height of the cube. The height of the cone will be the height of the cube. What's the height of the cube? 4.2 centimeters, not 2.1. Height of the cube, length, breadth, height of the cube is 4.2. So a cone with these values is the biggest cone that can be drilled from this cube. You have to find the radius and the height of the cone. So since we can draw a circle touching all the four sides of a square, the maximum diameter the circle can have is 4.2. So the maximum radius is 2.1. And the maximum height will be the height of the cube itself, 4.2. So the volume of the cone is 1/3 pi. Should we take for pi? Nothing is given. So 22/7, 1/3 pi r square, 2.1 and 2.1 into h, 4.2. So 7 ones are 7, 0.3 times. Then 3 ones are, you can cancel this 0.1 times. So on multiplying 22 into 0.1 into 2.1 into 4.2. 19.404. Yeah, so which is option D, 19.4. Correct. Just a second, children. Any questions, children?
No, ma'am.
It's not exactly 19.4, it's 19.404. So in the option, this is the closest value we find, 19.4. Yeah. Now, can we discuss beyond this, or should you continue working? Because I don't know if you've gone beyond the 6th one. Yeah. Has anyone completed working all the sums till the 10th one?
No, ma'am, up to 7.
Okay, so I think we just go ahead. Okay, so we'll do the 7th one then. Has most of you completed the 7th one?
Yes, ma'am. Yes, ma'am.
Okay, then we'll see the 7th one. So in question number 7, a solid spherical ball fits exactly inside the cubical box of side 2A. The volume of the ball is. Yeah, so here, what will be the diameter of the spherical ball? 2A. 2A. The diameter is 2A. So the radius will be A. And the volume will be 4 by 3 pi r cubed. So 4 by 3 pi A cubed, right?
Yes, ma'am.
Yeah. So it's option D. 4 by 3 pi A cubed. So in a cube of edge 2A units, a spherical ball just fits into the cube. So the radius of the spherical ball will be, the diameter is 2A. So the radius is A. And the volume of the ball will be 4 by 3 pi r cubed. R is A, so A cubed. 4 by 3 pi A cubed. Option D. Yeah, please go ahead, children. I think another 10 to 15 minutes, you should be able to complete. I'll come back at about 9:35. Please continue working. Yeah. Let's see the answer for the 8th one. As if you had texted something. What is that? Mm. I don't understand what you're saying. Okay, Hassan, fine. All right, so now Swati, you're saying for the 8th one. Okay, let's see that. Children, we're seeing the answer for the 8th one. A cube of side length 66 centimeters is filled with spherical metallic balls of diameter 0.6 centimeters, and it is assumed that 5/8 space of the cube remains unfilled. What are the number of balls that can be filled in the, what are the number of balls that can be filled in the cube? No, I didn't get the question. I just want to read it again. A cube of side length 66 centimeters is filled with spherical metallic balls of diameter 0.6 centimeters, and it is assumed that 5/8 space of the cube remains unfilled. Okay, all right. So what are the number of balls that can be filled in the cube? So I think they're asking about filled, which is already filled. Okay, let's see. So now 5/8 is unfilled. So how much is filled? 3/8 is filled. 3/8 is filled. Now what's the side of the cube? 66 centimeters. Okay. So edge of the cube. Now the space occupied by the, the spherical balls. Is 3/8. So the volume, the space occupied by the spherical balls is 3/8 of the volume of the cube. 3/8 because 5/8 is not filled. So 3/8 is filled. 3/8 of the cube is filled with the spherical balls. So how do you find the wall? So that means what? Volume of, you can write this itself. Volume of all the spherical balls. Volume of all the spherical balls is equal to 3/8 into volume of the cube. So volume of all the spherical balls, 1 is 4/3 pi r cubed into n. 4/3 pi r cubed is the formula to find the volume of one sphere. Like that, how many spheres? N. So n into 4/3 pi r cubed is the volume of all the spherical balls. And this volume is equal to 3/8 of 66 into 66 into 66. So n into 4/3 into any instruction, yeah, 22/7 into r cubed. That's what we, oh no, radius 0.3, right? 0.3, right, children? Diameter 0.6. So 0.3 is a radius. So let me take it as 3 by 10. 0.3, which is 3 by 10. 3 by 10, 3 by 10, 3 by 10 is equal to 3 by 8. See, 5 by 8 is unfilled. 5/8 is unfilled. So how much is filled? 1 minus 5 by 8, which is 3 by 8. 3 by 8 of the volume of the cube is filled with the spheres. So volume of all the spheres is equal to 3 by 8 of the volume of the cube. So we have, I'll cancel everything after transposing. So n is equal to 3 into 66 into 66 into 66 into all this 3 and 7. Okay, this 3 and 3 straight away. Okay, I'll just cancel everything here, children. So this 3 and 7 and 10 and 10 and 10 in the numerator divided by the 8, 66, 637, yeah. 8 into 4 into 22 into 1, 2, 3. Okay. So 22 ones are 22 threes are. So 3 and 3 here. Then this 2 threes here and the 2 threes here. And then 4. So like 2s are and 5s are. Again 5 and this 2 gets cancelled. And now this 8 4 times 8. 2 4s are, so it will be 233 times. Again 2 times 33 times. 2 1s are and 2 5s are. Okay, so we are left with nothing in the denominator. In the numerator, we have 33. We have another 33. We have a 7. And we have 125. I'm getting 952,875. N is equal to 952,875. 952,875. Yeah, option B. Yeah, children, please let me know which part I have to be more clear. See, we have understood one thing. Whenever we work with volumes and surface areas, it's important to understand the information given in the question in words. Like you need to construct the equation in words. So here the equation in words is volume of all the spherical balls is equal to 3/8 of the volume of the cube. That is the equation in words. Volume of all the spherical balls is equal to 5/8 is empty. So how much is full? 3/8 is equal to 3/8 of the volume of the cube. That's the equation. Now write the formula. One sphere 4 by 3 pi r cubed. All the spheres n into 4 by 3 pi r cubed. N meaning number of spheres is equal to 3 by 8 into volume of the cube is 66 into 66 into 66. Then substitute the values. 0.3 I've taken it as 3 by 10. Then on transposing and simplifying, we get the number of spheres is equal to 9,52,875. Yes, Swati, where should I help you?
No, ma'am, I framed it correctly but went wrong in simplifying.
Okay. All right. So let's move to the ninth one. A hollow cube of internal edge 22 centimeters is filled with spherical marbles of diameter 0.5 centimeters, and it is assumed that 1/8 space of the cube remains unfilled. Then the number of marbles that the cube can accommodate is okay. Okay. So, so when the marbles are filled, 1/8 space of the cube remains unfilled. So how much is filled? 7/8. 7/8 is filled. So volume of all the spheres or all the marbles is equal to 7/8 of the volume of the cube. So same thing, n into 4/3 pi r cubed is equal to 7/8 into h cubed. Yeah, what's the answer for this one?
From 1,42,396.
So option B, is it?
Yes, ma'am.
What about the others? So 22 into 49 into 6. 49 into 6. I'm getting yeah, and this is the correct answer. 9A. Yeah. Nine A is the correct option, children. This is similar to the earlier one. You have to ask me. See, if you want something more clear, please ask me. Any questions? All right. No response. The next one. So the diagram is given there, and you can see all the parameters are marked there, radius and height. The question is, you need to find the area of the paper required to cover the model. Yeah, we need to find the area of the paper needed to cover the model. So where all will you see model, meaning you'll be able to lift it, right? So he has to make it and carry it to school. So he can lift the model. What you see there, that figure is the model. That figure is the model. So that means he has to cover the base of the cylinder, the CSA of the cylinder, and the CSA of the hemisphere. The model is a cylinder surmounted by a cone. You can see the figure in the book. I'm sorry. You can see the figure in the images I've sent on WhatsApp. So the model is a cylinder surmounted by a hemisphere. Now, if Abhinav has to, cover the model with decorative paper all over, entire model, yes. So the area of the paper needed will be the area of the base. It's a model. You can lift and you can cover the base, right? It's not fixed to the ground. So you can see the base of the cylinder. So area of the base of the cylinder, CSA of the cylinder, and CSA of the hemisphere. See, we should not forget the bottom of the cylinder. It's a model. You can lift and cover the bottom. So area of paper needed is equal to area of the base of the cylinder. Sorry. Yeah. Area of the base, pi r square. CSA of the cylinder, 2 pi RH, and the CSA of the hemisphere, 2 pi r square. So you can add pi r square and 2 pi r square and make it 3 pi r square. So 2 pi RH plus 3 pi r square. So you can also take out common because r is the same for both. So common is pi r. So you get 2h plus 3r. So 22 by 7 into r is 7, 2h. The height of the cylinder alone is 21. It's marked there. The height of the cylinder is 21. So 21 into 2. Three R. So 21. So 7 gets cancelled. 22 into 63. 22 into 63. So I'm getting 1386. Yeah. You have to share your answer.
Same, ma'am. 1386.
Got the same.
Correct?
Yes, ma'am.
Perfect. So the model, you can cover the base pi r square, you can cover the CSA 2 pi r h and the hemisphere, the CSA of the hemisphere 2 pi r square. Any questions, children?
No, ma'am.
No, ma'am.
Okay. Okay, let me just check how much of statistics you remember. Just a simple question. The upper limit of the median class interval. Median class interval is dash, is your question. The upper limit of the median class interval is. Answer this. I hope all of you are working on this one. Okay, what's the first thing you would do?
And we find the cumulative.
Cumulative frequency.
Okay, then what's the second thing you would do?
And find the sum of the Fi column and then divide it by 2 to get n.
No, no. Okay, then after that? Okay, fine. Tell me the answer. Tell me the answer. Yeah, fast. What's the answer? Okay, Hasif has given his answer 16.5. Okay, I must say I'm disappointed.
Ma'am, 17.5.
17.5, is it?
Yes, ma'am.
Bhavishya, okay. Hasif says 16.5. Let's see. So the first thing, according to me, you should be doing is to make the class intervals continuous. For median and mode, you must ensure that the class intervals are continuous. If they are not continuous, make them continuous. That's the first step. So minus 0.5. You're not sure, Hasif. Okay. Make the class intervals continuous. That's the first step. So minus 0.5 to 4.5. Oh, sorry, 5.5. Correct? Are my values correct?
Yes, ma'am.
So you need to make the class intervals continuous. That's the most important thing. Make the class intervals continuous. And now find the total of the frequency column. So that will be 57. N is equal to 57. Now you need to find N by 2. 57 by 2. So it's 28.5. Now in the CF column, this is the value that's just greater than 28.5. So the corresponding class interval, this one, is the median class interval. This is the median class interval. And the upper limit of the median class interval is 17.5. Correct. I think Niveda has given that answer. And Bhavishya also said 17.5.
Yes, ma'am.
Okay. Okay, so on WhatsApp, I can see Niveda and Hasif have mentioned 17.5. Good. So make the class intervals continuous. For median and mode, you have to make the class intervals continuous. Make the class intervals continuous. Then write the frequencies. Find the cumulative frequencies. N is equal to 57. The total of the frequency column is 57. You can add and check. N by 2, 57 by 2, 28.5. Now in the CF column, the value that is just greater than 28.5 is 38. And the corresponding class interval, 11.5 to 17.5, is the median class interval. And you can see that the upper limit is 17.5. All right.